If you've ever found yourself clicking the exact same sequence of buttons, filling out the same fields, or, running the same complex financial report every single morning, you get it.
Oh, absolutely.
You understand that fundamental human desire for automation. We all want our machines to handle the rote tasks so we can focus on, more important work.
That's the core of it, really. When we talk about an automation app, we're talking about software designed specifically to absorb and execute those repetitive tasks.
And the scope is huge, right?
It's enormous.
Yeah.
It could be something as simple as automatically forwarding an email, or as complex as launching and tracking an entire sales campaign. And critically, these tools work everywhere. Your phone, your computer, across your whole professional software stack.
And today we're taking a deep dive into that entire spectrum for you. Our mission is sort of threefold. First, we'll map out the range of tools available, from the absolute simplest entry points to really sophisticated connectors.
We'll get technical.
Very technical. We'll move into professional mobile testing, and we're going to dissect the architecture of a tool like Appium. And finally, we'll tackle a crucial real-world problem. The significant legal risks you run when you try to use this power to automate a third-party app like Blinkist. Okay, let's unpack this, starting at the shallow end of the pool with the macro. For someone who's just curious, who wants to get started without learning Python or Java, what's the key difference between a macro and, actual programming?
It's all about the author. In traditional programming, you are manually writing every single line of instructions.
The coder.
You're the coder.
Yeah.
But with a macro, you, the user, just do the steps once. You click the buttons, you input the data, and the software automatically records those actions and turns them into a script. You get the code without writing it.
So the barrier to entry is extremely low. And the sources break down macros into two main categories, right? Based on how powerful they are.
Correct. The first is the application macro. This is recorded and executed entirely inside a single piece of software. The classic example is in Microsoft Excel.
Right, I've used those.
You might record a complex data formatting sequence. It often uses a language like VBA, Visual Basic for applications. It's powerful, but it's stuck inside Excel. It can't talk to anything else.
But the real power comes when you let the automation move beyond just one app.
That's the generic macro, or what we just call operating system level automation. This works at the OS level, meaning the task can span any number of applications you want.
So back to our financial analyst example.
Exactly. They wouldn't use a simple Excel macro. They use a generic one to open a browser, log in, download a data file, save it, and then open it in the spreadsheet to do the work. All one automated sequence.
That immediately sounds much more useful. So if you're starting out and want that power but still want to avoid code, what are the best entry points?
If you're looking for sheer simplicity, IFTTT, if this did, then that is still the gold standard. It's built on simple conditional logic, applets, like mute my phone when my calendar says I'm in a meeting. It's just plug and play.
And moving one step up the complexity ladder, for connecting, say, business apps.
That brings us to Zapier. It's incredibly popular because it connects hundreds of different tools. And what's fascinating now is its push into AI. A user can literally describe a workflow in plain English.
Right what?
Like when a customer submits a form, create a contact in Salesforce instead of follow-up email. And Zapier just helps build the whole thing for you.
And what if your focus is strictly on browser productivity?
Then you'd look at Bardeen. It's usually a Chrome extension, and it's built for speeding up repetitive UI tasks in web apps, like scraping data from LinkedIn or filling out forms in Google Sheets. It's really for that individual power user.
Okay, so we've gone from simple keystrokes to AI workflow builders. But here's where the technical stakes shift, and they shift dramatically. We move from saving a few minutes a day to the core quality assurance process of a major software company. What's the fundamental difference in approach there?
We transition fully into what's called automated UI testing. The goal isn't just personal time saving anymore, it's quality control. It's about speed and scalability.
You want to catch bugs faster?
Exactly. You're releasing software daily. You need rigorous testing to catch front-end bugs as fast as possible. This eliminates the need for developers to spend hours manually clicking through every single feature before a release.
This brings up a crucial aha moment from the sources, the debate over how you even define the user interface. Most conventional tools, like Selenium or Cypress, they aren't actually looking at the pixels on the screen, are they?
No, they're not. They're testing a proxy for the UI, which is a key insight. They interact with the underlying code, the DOM locators. Think of them as the street address of a button on a web page map.
So the script clicks 123 Main Street.
Right. But But this requires programmers to maintain all that code, and they can easily miss visual bugs. The code might think a confirmation message appeared, but a human would see it's actually hidden behind another pop-up.
So how does true visual layer testing with tools like Rainforest QA, how do they overcome that blind spot?
They try to simulate how a real human interacts. These tools use pixel matching. They don't just ask if the code is there. They verify that the button is actually visible, that it's the right size, the right color, and has the right text. It's much more robust.
And this professional QA mindset brings us directly to the central tool we need to understand, Appium.
Right. Appium is the leading open source framework in this space. Its biggest advantage is its universality. You write one test script in, say, Python or Java, and it can run that same test across both Android and iOS devices.
And here's the key, right? It does this without needing to modify or recompile the app being tested.
Which is absolutely crucial in a professional environment. You don't want to test a modified version of your app.
Okay, that is the technical magic we need to break down. If I'm writing a Python script on my laptop, how does Appium know which specific device I want to target, and how does it even talk to the app?
That context is delivered right at the start. When your script, the client, wants to start a session, it sends a request to the Appium server. And that request includes these key value pairs called desired capabilities.
Desired capabilities.
That's just essential setup info. It tells the server exactly what environment to use, platform name, Android, the OS version, maybe even a specific device name, Google Pixel 7 Pro.
And once the server gets this request, what's the protocol? How does it understand commands like tap this button?
It uses standardized web protocols, either the older JSON wire protocol or the modern WebDriver protocol. This is the common language, the Esperanto of automation. It lets a script in Java send the exact same command as a script in Python.
So the Appium server, which is running in Node.js, gets the command. Then it has to translate that for the device's specific operating system. How does that translation bridge work for iOS versus Android?
The server is the central translator. If the desired capabilities say iOS, the server relays the command to the XUI driver, which is Apple's native testing framework. If it's Android, the server uses either the UI Automator 2 or Espresso driver, which are Google's native frameworks.
And if we dig into the Android side, there's a small, specific file that does the actual work on the device, right? Why is that needed?
Yes, that's where bootstrap.jar comes in. See, Appium can't directly inject commands into the app itself, so the UI Automator framework talks to bootstrap.jars, which is installed and running on the device, be it a real phone or an emulator.
And bootstrap.jar is like a little server.
It effectively acts as a self-contained TCP server on the device. It receives the translated commands from Appium and is responsible for actually executing them, finding the button and tapping it within the device's environment. It's a really clever bit of architecture.
So we're talking about an incredibly sophisticated, multi-layered system designed for professional QA. This leads us perfectly to our dilemma. Taking this powerful engine and using it on a consumer app like Blinkist to force it to do things it wasn't designed for.
Like continuous looping or shuffling summaries.
Exactly. Since Blinkist doesn't provide a public API, an official way in UI, automation is really the only way to do it.
It is. And this isn't a quick script you knock out in an afternoon. This requires some serious engineering work.
What does that actually involve?
Well, an engineer would first need to use a tool, like the Appium inspector, to find the unique locators, those IDs or XPath addresses, for every single element. The play button, the next button, the title, the progress bar.
You have to map the whole interface.
You do. And then you have to write complex code, not just to click, but to monitor the playback status. That might mean constantly checking the progress bar to see if it's hit 100% before you tell it to click the next title. It's complicated.
And even if you pull that off, you immediately face the drawback that plagues every UI automation project: flakiness.
The script is built entirely on sand. It relies 100% on the dynamic UI staying exactly the same. If a Blinkist developer decides to update the app, maybe change the layout, or even just rename one single element ID,
your whole script breaks.
Instantly. It's called flaky automation. For a reason. I've spent days troubleshooting a script, only to realize a developer had changed a button's background color, which threw off a timing calculation. It's incredibly frustrating.
So you manage the high technical hurdle, you deal with the fragility, and then you step directly into the legal minefield. What's the biggest legal risk for someone who automates a third-party app, even just for personal use?
The most immediate and significant risk is breach of contract. Specifically, you're violating the app's terms of service, or 2S.
The thing we all click agree on without reading.
Exactly. When you install Blinkist, you agree to their terms, and those terms almost always prohibit unauthorized access, automated manipulation, or scraping.
What's the real consequence of that breach? Are they going to sue one person?
A lawsuit is unlikely for a single user, but the consequence of account termination is very real. You get banned. You lose access. You lose any notes or save progress. If you rely on that platform, that's a huge penalty for breaking the contract you agreed to.
And what about intellectual property?
There are two prongs there. First, copyright infringement. If your script is scraping or copying the summaries for use outside the app, that's a direct violation.
That one's obvious.
The second is more complex, a DMCA violation, the Digital Millennium Copyright Act. If Blinkist uses any tech, like DRM, to protect its content, and your script gets around that protection, the act of circumventing it is itself illegal, even if you never share the content.
So it sounds like the moment you deploy code to override the intended experience, you're not just a user anymore.
You're absolutely right. You're attempting to exert engineering control over someone else's platform. And while simple automation for personal convenience is a bit of a gray area, the risks account ban, loss of service, they need to be weighed against the gain.
Which highlights why sometimes the simplest answer is the most elegant one. Before you spend 40 hours building a fragile, risky Appium script, the sources suggest a far simpler audio alternative.
Absolutely. The zero-code solution is often staring us in the face. If you're a premium subscriber to a service like Blinkist, they often let you download the audio files.
For offline use.
Right, so you just take those files, import them into Apple Music or Spotify or whatever, and use that player's native shuffle and loop functions. Problem solved. Zero legal risk, zero flakiness.
We're also seeing this kind of automation play out in the information overload space, where AI is now automating the summary process itself.
Yes, this is automation applied to content analysis. We see tools like Gemini in Google Docs, where you can highlight a huge document, right-click, and just hit Summarize.
And the summary apps themselves are adapting.
They are. Blinkist Pro, for example, now offers an AI service to summarize outside content, like a PDF you upload or a video transcript for an extra fee.
And finally, relating this back to our own work, this idea of strategic choice versus script automation matters even in how we deliver content, like in this deep dive.
It really does, and this is where context is everything. For podcasters, the source material notes that using native chapter markings or timestamps in the audio can actually be counterproductive.
How so?
It invites the listener to skip around, which lowers the all-important listen-through rate.
Right. And currently, those timestamps offer very little SEO value on the big platforms. So the smart automation strategy is a human one. Instead of scripting a marker, you use descriptive bullet points in the episode description.
Exactly. Questions or key takeaways. That plays much better with Google's algorithms, it guides the listener, and it respects the narrative flow we intentionally build. Sometimes the best automation isn't the line of code.
So, to summarize our deep dive, the world of automation spans from the immediate, simple conditional logic of IFTTT all the way to high-level mobile QA engineering with Appium.
And that engineering requires a deep understanding of client-server communication, JSON protocols, and native drivers like Bootstrap.jar to get the job done on the device.
But the moment you take that sophisticated tool, which was designed for internal controlled testing, and you point it at a lockdown consumer app, you're taking on a huge technical risk because of that flaky dynamic UI.
And a substantial legal risk tied to the terms of service, copyright law, and potential DMCA violations. The lesson for the learner is pretty clear. The most powerful tool is rarely the most practical or the safest choice for a simple personal goal.
Which brings us to our final provocative thought for you to consider. In this modern quest for greater digital control and customization, sometimes the most technically complex path UI automation is also the one most vulnerable to failure and the one most likely to invite legal trouble. Before you start a high-stakes coding project for a simple outcome, maybe just take a moment to ask yourself, is my effort better spent building fragile code that might break next week, or finding the simpler built-in feature that already